Hello and welcome to the Cloud Noob. In this video, we're going to be covering some topics using examples from a perspective of someone who wants to learn about cloud and has questions like, what exactly is the cloud and what is cloud computing? In this video, we expect that you have some knowledge of basic concepts like HTTP requests and response, virtualization, and containerization, although it's not expected that you are an expert in these topics. Let's consider a simple notes application on your favorite app marketplace. The application can take notes, store them, and retrieve them on demand. The user accesses the application over the internet wherein they can post a note and view previously posted notes. These actions can happen using HTTP requests, and to each HTTP request, there will be an HTTP response. The application, in its most basic form, contains three things. First, there's some form of a compute layer which runs the application code. Second, a database for storing data. And last but not the least, some form of load balancing for distribution of requests to the compute layer resources. Now you may be wondering, why am I boring you about what the Notes application comprises of and when does cloud come into the picture? So remember the compute server, the database, and the load balancer that I had referenced earlier? Let's start by understanding where these can live. The application publisher can purchase a server or some servers and host the different parts of the Notes application on these servers. In case the application is very resource intensive, meaning it can generate significant traffic and requires more than a few servers, it can be hosted in a data center that the application publisher can build and manage. Now, what's common in both these scenarios is that the publisher needs to purchase the required servers, then has to manage these servers themselves from the hardware to the software running on these servers. And the result is a great deal of work for publishers and an increase in management costs. This is where cloud can help. So you must be asking, what is cloud? In basic analogy, cloud is the ecosystem of resources and services, storing information or running code on services over the internet, and accessing them from the internet instead of one's hard disk or self-managed infrastructure. Some everyday examples of cloud applications would be Google Drive to store files. The files on your Google Drive can be accessed from anywhere with an internet connection. Then there's Gmail, which is an email client that lets you access your email from anywhere with an active public internet connection. And additionally, there are similar applications out there like Dropbox, SharePoint, and many more. Let's see what's the difference if you want to set up a data center versus using the cloud. To set up an on-premise data center, you need to purchase equipment that can take months from placing an order to installing it. With cloud providers, you can register and start spinning up resources with as simple as a couple of clicks. On-premise equipment often requires an upfront payment, which increases the risk if not needed for some months down the road. With cloud, you only pay for what you use. With the on-premise setup, you'll need to maintain and manage hardware, such as regular wear and tear, and for software, there is patch management. With cloud, the providers manage the underlying hardware, and with a lot of offerings, manage the patching of the servers as well. With on-premise servers, you have a better way of ensuring a single tenancy for compliance purposes. However, you share the underlying architecture for most use cases with the public cloud. Some of the offerings can have reserved tenancy for some additional costs as well. Most importantly, you have to take care of service security yourself with the on-premise setups. In contrast, with cloud, you have a shared security model wherein the cloud provider looks after their service security. You take care of the security of your application, for which the cloud provides various offerings and recommendations to use them. That was a lot. Now it's time for an example. Data centers consist of servers meant to offer particular compute capabilities. Cloud providers spend a lot to build and manage massive data centers all across the globe that are connected via networking. These cloud providers host several services that can be accessed through API requests through the internet on these data centers. However, Virtualization creates some abstractions between the services and the hardware infrastructure. Our friendly app developer, Appy, pun intended, wants to host an application and wants to use some virtual machines to host her code. Now let's see a database to store the data as well. Appy registered with a cloud provider which boasts massive scalability. With the help of simple clicks, Appy created virtual machines needed to host the code and databases, or even better, use cloud-specific database offerings. These offerings run on the infrastructure that the cloud provider is managing. So now, even though Appy has not purchased servers directly, she can still be able to work on the infrastructure that the cloud provider built and manages. Appy is happy that she can concentrate more on doing the development. Let's check out the different types of clouds. The main divisions are public cloud, private cloud, and hybrid cloud. In the case of the public cloud, third-party providers offer services over the public internet, and anyone who can pay for these services can use them. With this model, essentially you pay for what you use, which is because of the massive scale of economies, meaning that there are a lot of users using these services. The cloud provider maintains a standard service structure for all of these users. It can become very cost efficient. Because of the users sharing the underlying infrastructure, it makes it easier to scale very high, very fast. Public cloud examples are AWS, GCP, which is Google Cloud Platform, Azure, IBM Cloud, and Alibaba Cloud. In the case of a private cloud, the computing resources are isolated and delivered to your organization across a secure private network that's not shared with any other customers. In this case, the stress remains on per use case customization to meet the company's unique business needs. Use of private cloud is usually for use cases wherein some compliance requirement requires resources to strictly not be shared with other tenants. HP, VMware, Dell, and Oracle are some of the leading vendors for private cloud. And the third type of cloud is a hybrid cloud, which can be a combination of more than one public and private cloud. Hybrid cloud aims to provide a sweet spot for single tenant compliance, flexibility, and cost efficiency. The rest of the video, I'll be focusing on public cloud. Now let's understand the different types of cloud computing. The first one here is Infrastructure as a Service, or IaaS. For Infrastructure as a Service, the cloud service provider offers infrastructure for you. As a user, you essentially rent the infrastructure and control things like the operating system, applications, and middleware on this infrastructure. Here in the image, the red items are the things that the cloud service provider manages for you, and the teal items would be the ones that you as a business user have the ability to work on. Infrastructure as a service enables you to have the most control over your environment, but you also have to manage a lot more things. Examples of infrastructure as a service are Amazon EC2, Google Compute Engine, and Azure Virtual Machines. Next up, we have Platform as a Service. With this type, the cloud service provider manages for you some more important things which help you focus more on the development and increasing agility. With this, there is a layer on top of this underlying infrastructure that helps with the management of things like runtime, operating system, and middleware, such that you would just need to manage the applications running on the top of this layer. In return, you lose control over most of these provider managed configurations. Examples include Google App Engine, AWS Elastic Beanstalk, Heroku, amongst others. Then we have Software as a Service, or SaaS. These are essentially full-fledged softwares that can be accessed over the internet that serve a specific purpose. Needless to say, you don't have a lot of control on how the software works on the back end, but all of that is abstracted to be accessed using APIs and optionally a dashboard UI. Typical examples of these are web or mobile applications that can be accessed over the internet. Examples of SaaS providers include Salesforce, Workday, Concur, and popular SaaS offerings such as Google Drive and Gmail, amongst others. Now, this is where things get interesting and even more modern. Function as a service can also be called as a subset of platform as a service and provides a platform to run your code without taking care of underlying infrastructure. So essentially, in this case, the cloud provider manages both the underlying infrastructure, and all you need to do is push your code to the platform, which can run on demand or in some event-driven architecture. Think of it, you can get to run your code and you don't have to manage a single instance of server. How cool is that? This is where the concept of microservices is highly applicable, and you can have your different functions acting as a backend compute for different microservices. Example of this include AWS Lambda functions, Google Cloud functions, Azure functions, amongst others. Container as a service is yet another subset of platform as a service, and again, something which is being adopted very fast by a lot of organizations. With this, the cloud provider takes care of container orchestration and underlying infrastructure management for you, and all you need to do is push containerized applications with relevant configurations like the Docker file, memory needed, and number of containers or tasks or instances that are needed. This is different from function as a service, as with this, you deploy containerized applications, however, with function as a service, that may not be necessary. Examples of container as a service include Amazon ECS, Elastic Beanstalk, Google App Engine, Cloud Run, Azure App Service, amongst others. Finally, after all of these foundational concepts, let's take a look at what are the benefits of cloud computing. First and foremost, you only pay for what you use, instead of high upfront investment for procuring the equipment, which gets you started off the ground almost instantly. With cloud providers building their services and offerings on a large scale, and these being available to and used by a large number of customers, this helps making it even more cost effective. This in turn gives the cloud provider the ability to invest better in more services and offerings to further benefit their customers. Scalability is a beast when we consider most public cloud services. For example, Amazon S3 and Google Cloud Storage boast of almost infinite and instantaneous scalability. With lesser management on underlying infrastructure, developers can focus more on development activities. With cloud, you don't need to stress over management of data centers, and even if you are following a hybrid model wherein you have cloud and on-premise data centers, the part which uses the cloud will have less management requirements that the cloud provider will take over. You can go global literally in minutes with a lot of different offerings like Cloud CDN and CloudFront, along with different regions that can be leveraged to deploy applications. Public cloud providers have a shared security model wherein they will take care of the services security and you need to take care of application security, for which as well the cloud providers provide recommendations, services, and tools. One of the best advantages is that you get to use the same cutting edge technology as all the other customers, be it big or small organizations, and again, you only pay as you use. Lastly, the benefit is a huge one for me personally is that most of these cloud services provide purchase carbon credits and the future expect to go completely carbon neutral with their data centers, which can be a huge impact on the environment. That's it, folks. This was the end of this video. Thank you so much for watching. I hope you found the video useful. I request you to like this video, subscribe to the channel, and comment any feedback, questions, or requests that you might have. This will make me better at the videos I provide and maybe help with that YouTube algorithm. Till next time!